Hi, my name is Wallace and I am a lecturer on the development of mobile software for... Hi, my name is Wallace and I am a lecturer on the development for mobile platforms, specifically iOS currently. My doctorate research was on wearable computing for supporting mobility of blind pedestrians. All this I have done inside the Department of Informatics in any university I've worked for, usually the software engineering research group. Before working for the universities, I was an IT consultant for 12 years in software development for several platforms, including PL/SQL for Oracle, web services and applications with Java, among others. So before proposing a course and talk about a particular topic with you, I would like to share my teaching philosophy with you. So I have this motto that was coined in 2011 by me and my colleagues in our research group during the doctorate. And there is a reason why I put this under quotes and I say theories are delivered as demanded by projects. Well, the word theories was put there purposefully to avoid putting lectures, because lectures is just one way we used to share knowledge with the students, but we were much more interested in live coding sessions and workshops and other kinds of activities, and we didn't want to limit our motto to one kind of activity. The fact that it's demanded by project means that we would only lead a learning activity, a lecture, a workshop, whatever, about any topic only after the students are already in need of that knowledge. They are in need for the development of project in that case. And also it should be short and interactive, as short and interactive as possible in order to keep that constant feeling of a workshop. Well, one reason why I avoided the word lectures is because, for instance, for teaching computer programming, live coding sessions can be quite effective. While other conceptual topics, I think they can be effectively shared through interactive lectures. So regarding assessment, I think it should be a means to reinforce learning and point directions for improvement. And all starts from an evidence of learning. So you have to do something so I can assess. So while you improve your proficiency with the help of qualitative advice over any of the artifacts you produce, only the final version of each evidence of learning is used for grading. So you have the freedom to produce many versions of your artifact and getting advice from the teacher. So now let's discuss this a little bit. Well, I believe assessment should be part of your learning process, not only in the end of it, as in summative assessment, but formative assessment. So during the journey, as a way to give students advice in directions for improvement. And most of all, I want assessments to have meaning for the student. A teacher, when he assigns a grade, he knows how much each topic in the syllabus represents and how much it contributes to the final grade. Students, however, they could benefit on having more qualitative assessment attached to the grade, as a way to giving meaning to it. More than doing it in the end, when you have less opportunities to recover, I believe we should discuss it periodically, bi-weekly for instance, or as I usually do during the milestones of the project. The challenge for the teacher is that it increases a lot the workload. To begin with, qualitative assessment is much more time consuming than just grading. Additionally, to the fact that doing qualitative assessment, you may bring the same artifact many times for getting advice. And it will require the teacher to assess the same artifact several times before the final version be presented and used for grading. So I say it is time consuming and challenging for the teacher. So the reason I take this approach is because it contributes to a meaningful mentoring relationship with my students, which I have seen as a very mature and positive way of educate them. I can share skills that don't fit in a lecture. Very often, I share my reasoning on a particular problem when we discuss alternatives for the student's project. I believe this is one of the best contributions teachers can give to their students. So, I was talking about evidences of learning, and you might be asking yourself what I mean with that. Well, for me, an evidence of learning can be that singleton design pattern that you implemented in your project, or your explanation of why you chose this particular solution for the problem you have. I don't like to artificially add requirement to the project, so it might be the case that you will never need to use a particular design pattern in your code. Therefore, we could look for other evidences of learning that you learned this design pattern. For instance, you could leave a live session in the lab teaching your colleagues. This is a way for fostering peer learning. So I offer you all the support in preparing the activity, I review it with you, and you lead the session. What I want with that is that you be a source of knowledge for your colleagues, to create a community of collaborative self-learners in the department. There also might be the case that for a particular learning goal, you prefer a written exam, or we might decide the final project as an essay or an oral presentation. So all this are potential evidence of learning that must be seen in context for each course, for each particular situation. So that said, let's think about the course. So in order to decide what course to propose and what partial lecture I would share with you, I started looking the study program of some courses, particularly technical computer science and business IT. They intersect many times, and I like it because it brings diversity of background to the groups of students, which enriches a lot the learning experience in my opinion. The first module I saw was the Purse of Computer Science, the one whose final project is a tool for sentiment analysis of tweets. I could see a neat mobile application added to it. And as a teacher for mobile development, I could potentially propose something new that is compatible with the current learning goals of the course. But then I kept looking and I saw the second module. The second module is interesting because it intersects with business IT. I would rather make a recommendation on this module. And I felt a strong affinity with that. But I kept looking, and the fourth one is very interesting. It's common for the two programs as well. I was very interested in proposing something here. However, I have the practice of matching the content with the learning activity. For technical topics like computer programming, I would rather make a live coding session with all of you in a laboratory, and having confirmed that you all have the integrated development environment installed, configured, and running in your computers. Well, actually, programming computers is one of those skills that I like to approach with more practical activities. So I will show an example of an activity for students from humanistics, non-STEM students. So for teaching algorithmic design, I like designing board games like this and use unplugged computer science techniques for helping students acquire the skills before approaching the computer to start coding. So have an idea of this. Look, this is a student of non-STEM students, Roberta, and they are designing an algorithm for drawing a square. For everyone who read the book of Simon Papert, Mindstorm, Student, Computers and Power for Ideas, the inspiration is clear. It's like the logo. But instead of using a computer and a turtle, like in the language logo, I wanted students to execute the code as if they were computers, so they can understand the algorithms by performing it. The student who is pictured in the beginning of the video had an aha moment during this activity, and these aha moments are what I wanted to foster as much as possible. Well, the reason why I use different techniques is because in that case, computational thinking, I see this as a set of skills, like defined by Janet Wing. So it's like riding a bike or dancing. You may read hundreds of books and read all the techniques, but it takes practice for you to master it. With non-STEM students, non-STEM students, I focus more on algorithmic design, as this is their entry point to this world. With computer science students, I design interactive activities for other skills like modeling, abstraction, or modularization of your systems, like decomposition, and so on and so forth. So the point is, I believe different topics require different approaches. There is no silver bullet. And particularly, tacit knowledge is difficult to transfer, and this is what makes it even more valuable. So, I didn't want to perform those activities for the reason I explained, so I kept reading the study program until I found this. This is what I have put my passion in the last years. My doctorate thesis is totally into these topics. I love to understand the effects of the technology we make. And I think it's a natural aspiration once you already have developed the software. You want to see how it performs, right? So the usual approach is to start designing with the user already in the process. The design is participatory, and so is the evaluation. The user is always in. It is a course that benefits strongly on the project approach, and a course in which I can apply all the teaching philosophy I told you at the beginning. So here it goes.